Okay, so in 11.1 I went over the parabola. 11.2 I'm gonna go over the ellipses. Okay, the second conic section. By the way, there's a handout on under handouts that summarizes all the conic sections that we're talking about, the equations, the axes, the center, and everything. Okay, so this is a summary under handouts on D2L. Everybody should look at that. Okay, so what is an ellipse? Let's define an ellipse. An ellipse is the set of all points P, X, Y in the plane, 2 dimensions. The sum of whose distances from 2 fixed points these 2 fixed points are the focal points or the foci is constant. In the case of a parabola that we did in 11.1, it was the distance between a fixed line and a fixed point that they had to equal. PA had to equal PF for P to be on the parabola, right? The distance between P and the directrix is the same as the distance between P and F. Now, this is different. This is like having a thread. We all know what a thread is. Cut a piece of thread and put a pen or pencil in the middle. So you fix the ends of the thread, and this is the thread, and you put a pencil here, and then you move the pencil all around. You try it at home. It's neat. You get what we call an ellipse. Okay, by moving the pen, the distance between point P and those 2 fixed points, the foci, is constant because it's the length of the thread. PF1 plus PF2 is constant, which is the length of the thread that you cut. That's how we get an ellipse. Any point on the elliptical shape, if you measure its distance from the first focus and its distance from the second focus and add them up, you get a constant. Okay, you get a constant. So now let's talk about several features of the ellipse. So elliptical shape, 2 focal points, I call them eyes. In the case of parabola, there was 1 focus. Here there's 2 of them. Okay, the line through the foci, so that line that goes through the foci intersects the ellipse in 2 points. Those are called vertices. A vertex, a vertex. In a parabola, there was 1 vertex. In an ellipse, there's 2 vertices. The chord joining the 2 vertices is the major axis. So this is the major axis. And the midpoint, halfway between F1 and F2 and halfway between V1 and V2, is the center of the ellipse. So to find the center, you measure the midpoint between F1 and F2, and it's the midpoint between V1 and V2, okay? And the chord that's perpendicular to the major axis through the center is called the minor axis. The chord perpendicular to the major axis, it makes it at 90 degrees and ends at the ellipse, is called the minor axis. So now we know that if you take any point, PF1 plus PF2 is constant. Now, if we, the ellipse can be vertical, okay? I'm only showing you horizontal, but it can be vertical. We'll get to that. So if I do this, just so I can get a nice formula here, hold on. If I take 2 vertices and 2 foci, F1, F2, V1, V2, and this is the center. Center is 0, 0. It's halfway between F1 and F2 and V1, V2. If the focus is C units away from 0 and the vertex is A units away from 0, So V2 is at A0, V1 is at negative A0, F2 is at C0, F1 is at negative C0. And this is the ellipse that we're talking about. So if you pick any point, F1 plus PF2 is constant. So if that point is right here, so PF1, how much is that distance? It's A plus C plus PF2, which is A minus C. That's a constant, and that constant is 2A. So that constant, so the thread that we cut and make an ellipse is, its length, it's going to be the distance between the two vertices, which is the length of the major axis. Always. Okay? That distance is 2A. That's very interesting. So now the standard form of the equation of an ellipse, the standard form of the equation of an ellipse centered at HK and major axis is 2A, minor axis is 2B. If you have a horizontal major axis, it's going to be x minus h squared over a squared plus y minus k squared over b squared is 1. In an ellipse, a is always bigger than b, always, okay? Because the major axis is bigger than the minor axis. So when a squared is associated with x squared, you know you're going to have, you know x is horizontal, you know you're going to have horizontal major axis, okay? If center is at 0, 0, so that means h is 0, so you get x squared over a squared plus y squared over b squared is 1. A is greater than b, don't forget that. And if you have a vertical major axis, it's going to be x minus h squared. Now the smaller value is with x squared and the bigger value is with y squared. And if center is 0, then it's going to be x squared over b squared plus y squared over squared is 1. Now remember, the foci, the focal points, they lie always on the major axis. C units from the center. They always lie on the major axis, C units from the center. So basically, let me show you these two cases. If you have a horizontal major axis, the center is at HK. So this is a vertex, this is a vertex, and the psi will be F1, F2. And this is the minor axis. Its length is 2b. The major axis, V1, V2, is the major axis. It's 2a. Now it could be vertical major axis, as we know. So V1, V2, this is the major axis. F1, F2, and this is the center. F1, F2. So the major axis is right there. It's always the bigger axis, and there's the minor axis. And their length are always 2a and 2b. Okay? So we can understand that better. Now we're gonna find a formula for relating A, B, and C. So if you look at a horizontal ellipse, remember the foci are on the major axis C units away from the center. This is B. So if we draw that, we have a right triangle. This would be using the Pythagorean triangle. This is that. This is P, and that's also square root of B squared plus C squared using the Pythagorean triangle. This square was C squared plus B squared, so square root of that. So PF1 plus PF2, remember we found that to be 2A, where any P on the ellipse. PF1 is square root of B squared plus C squared, and PF2 is square root of B squared plus C squared. So there's two of those. So divide by 2. Square, and you can see A squared equals B squared plus C squared. So A is bigger than B, and it's also bigger than C, as you can see from the graph. So this is the formula we will need a lot when we're doing ellipses, because sometimes we're given B and A, we need C. Sometimes we're given B and C, we need A. So this is the formula that's like the Pythagorean triangle, but it's A squared that equals B squared plus C squared. Number 8, page 797. Number 8, page 797. It says match the equation with the graphs. Load 1 through 4. Give reasons for your answer. So 8, you have 16x squared plus 25y squared is 400. So before we do anything, we want to write it in standard form by dividing by 400 to make it 1. 16 goes into 425 times. 20 goes into 1416 times. So you can see A squared is always the bigger value. So A is 5. B squared is 16. B is 4. So we have a horizontal major axis because the x values are bigger. So look at we have to have 5 and negative 5. So it looks like number 3, 5, negative 5, 4, negative 4, center 0, 0. That's it. Number 3 is the graph. Okay, there's an important feature of the ellipse. It's called eccentricity. Let's start with that. Definition of eccentricity. And it's labeled as E. It's not the same E that we know from logs. No, that's a different E. The eccentricity of an ellipse E equals the ratio of C to A, the ratio of the distance between the focus and the center to the ratio of the distance between the vertex and the center. Remember, C is square root of A squared minus B squared, right? Because A squared equals B squared plus C squared. So A squared minus B squared equals C squared. So C is that. So if E, so look, E is square root of A squared minus B squared over A. So if E is close to 1, if E is close to 1, for this to be close to 1, B has to be close to 0, because you will have square root of A squared over A, which is close to 1, A over A. So that means B is very small, which means if the minor axis is small, the ellipse is stretched, right? The ellipse is stretched. So we have a stretched ellipse, because the minor axis is small. It's going to be smaller than this E, okay? It's going to be smaller than this. If E is close to 0, if E is close to 0, which means the numerator is 0, which means A and B are close to each other, right? Which means A and B are close to each other, meaning we have a circular ellipse, right? If the major axis and the minor axis are close to each other, then it's almost circular. Let's look at more examples. 16, page 77. 16, page 797. So how do we graph the ellipse? It says an equation of an ellipse is given. Find the vertices for an eccentricity of the ellipse to tell the length of the major and minor axes and sketch a graph for everything. 4x squared plus 25y squared equals 100. So let's write it in standard form by dividing by 100. So x squared over 25 plus y squared over 4 is 1. So the bigger values are a's, so a squared is 25, so a is 5, and these are x values. B squared is 4, b is 2, these are y values. The center is at 0, so there's no h or k. So if you graph that ellipse, a is 5 and negative 5. B is 2 and negative 2. So we get an elongated ellipse somewhat. Okay, the vertices, this is V1, negative 5, 0. V2 is 5, 0. And to find the foci, we need C. We have A and B. A squared equals B squared, C squared. 25 equals 2 plus C squared. C squared, that's 4, sorry. C squared is 21. C is square root of 21. So from the center, we go with square root of 21, which is almost 4.5. So this is F2, square root of 21, 0. F1, negative square root of 21, 0. The major axis is 2a, which is 10. The minor axis always 2b, which is 2 times 2 is 4. And eccentricity is c over a, square root of 21 over 5, which is roughly 0.9165. It's close to 1, that's why you see an elongated ellipse. Now remember what I said at the beginning of chapter 11, we're going to embed 11.4 and 11.2, 11.1 and 11.3. So here's example from 11.4. Find center, vertices, foci, major and minor axes, and graph. 25 times minus 3 squared plus 4 times y plus 2 squared equals 100. So we're going to write it in standard form by dividing everything by 100. 25 goes into 100 4 times. 4 goes into 100 25 times. And 100 goes into 101 times. So the center in this case is not 0, 0, it's 3 and negative 2. Opposite, opposite. The bigger values are a, so a squared is 25, a is 5, and it's a y value. The smaller values are these, so this is an x value. So if we want to graph this, starting at 3, negative 2, the center, 1, 2, 3, 1, 2. So the center is at 3, negative 2. A is 5, it's a y value. From the center we go 1, 2, 3, 4, 5. So we are at 3 for x and 3 for y. This is a vertex. And then we go 5 down. 1, 2, 3, 4, 5. So we are negative 7. And 3 for the x value. Now the b is your x value 2 units to the left. So we're at 1, negative 2. And then 2 units to the right. We're at 4, 5, negative 2. So we get our graph. This is the major axis. Now we need the foci. Find the foci. A squared equals b squared plus c squared. A squared is 25, that's 4. C squared is 21. So C is square root of 21, roughly 4.5. So we're gonna go from the center. We're gonna measure 4.5 and get the focus. 1, 2, 3, 4. So that's the focus. And the coordinates, the x value is 3. The y value, we started at -2, and when we went up, so we added 21. Going down, it would be subtracting 1, 2, 3, 4. That's 5. So that's f2. The x value is 3. We started at -2, and then we went down root 21, so it's a minus. Up plus, down minus. The eccentricity, it's C over A, square root of 21 over 5, which is, if you do the math, square root of 21 divided by 5, so it's roughly 0.92. That's why it's elongated ellipse and not circular. The major axis is 10, and the minor axis is 4, 2A and 2B. Alright, so the next example is finding the equation. Usually we have the equation, so now find the equation of an ellipse centered at 0, 0 with horizontal major axis, and C equals 3, A equals. So it's centered at 0, 0, and we have horizontal major axis, so it's x squared over a squared plus y squared over b squared, right? The bigger value is with the x because it's horizontal major axis. So we have C and A, so x squared over 16 plus y squared. We need b squared. A squared is b squared plus c squared. 16 is b squared plus 9, so b squared is 7. And that's the equation. Okay, from section, from this section, again, we want the equation of an ellipse in standard form, where the vertices are -8, 0 and 8, 0. Foci are -5, 0 and 5, 0. So let's plot these points to get an idea what equation they're looking for. The vertices are -8, 0 and 8, 0. So obviously the center is 0, 0, right? It's the midpoint of the vertices. The foci are 1, 2, 3, 4, 5. That's -5, 0. 2, 3, 4, 5. That's 5, 0. So we have a horizontal major axis centered at 0, 0. So x squared plus y squared equals 1. Now a squared, obviously a is 8, so a squared is 64, and we have c is 5, so we need b. C squared is a squared plus b squared. C squared is 25, a squared is 64 plus b squared. No, a squared equals, I'm sorry, what's wrong with me? A squared is b squared plus c squared. 64, so b squared is 39. Y squared over 39 is 1. Okay, from 11.4, find equation of an ellipse if foci are -4, -3, and 8, -3, and length of minor axis is 8. So if minor axis is 8, right away b is 4 because that's 2b. Okay, so let's just get an idea what we're talking about here. We have two foci, one at 8, -3, 8, -3, and one at -4, -3. So obviously the center is not at 0, 0. The center is midpoint. So since center is midpoint of f1, f2, so it's going to be f1 and f2. You add them up, divide by 2. -4 plus 8 is 4 divided by 2 is 2. -3 plus -3 is -6 divided by 2 is negative. So there's where the center is at 2, -3, which we could have guessed. Center 2, -3. So the equation, as you can see now, it's x minus 2 square plus y plus 3 square. Now it's a horizontal major axis, so the bigger value is the a square with the x, and the smaller value is the y. B is 4, right? So b square is 16, so that's 16. We still need a square. To get that, we need c. C is the distance from the center to the focus. So how much is that from 2 to 8? It looks like 6 units, right? So a square equals b square plus c square. B square is 16 and 36, so a square is 52, and there's the equation. Okay, couple more examples. Find an equation of an ellipse. Find an equation of an ellipse if its eccentricity E is 1/9 and foci are 0 plus or minus 2. If you look at the foci, there's 0, 2 and 0, -2. So obviously the center is at 0, 0. It's the midpoint of f1, f2, and c is 2. That's what we get from there. And the major axis is the y-axis, so it's vertical. So it's going to be square over b square. The bigger value is the y. Y square over a square is 1. Okay. So remember, E is c over a, right? But c is 2, so this should be 2/18, right? For c to be 2, so a has to be 18. A is 18. Okay. Or if you don't want to do this, you can say 1/9 equals c over a. 9c is a, so a is 9 times 2, which is 8. That's another way if you don't want to sort it out. So we got a is 18 and we got c is 2, so we find b. A square is b square plus c square. A square is, what's 18 square? 320? No. What's 18 square? Hold on. 18 times 18 is 324. My bad. Equals b square plus 4, so b square is 320. So we got the equation x square over b square, which is 320, y square over a square, 324, equals 1. Okay, what if the equation of the ellipse was not ended form? That's from 11.4. So write the equation of the ellipse in standard form and graph it. 9x squared plus 16y squared minus 54x minus 64y plus 1 equals 0. So we're going to group the x terms together, the y terms together, and this is going to go aside. 9x squared minus 54x plus 16y squared minus 64y equals -1. Pull the 9 out, x squared minus 6x. Pull the 16 out, y squared minus 4y. So complete the square, take half the 6 and square it. Half the 6 is 3, 3 squared is 9. We're adding 9 inside the parentheses, actually adding 9 times 9, which is 81, to the left side of the equation. So we're going to add 81 to the right side of the equation. Half of the 4 is 2, 2 squared is 4. We're adding 4 inside the parentheses, but we're actually adding 16 times 4, which is 64, to the left side. So we're going to add 64 to the right side of the equation. Factor it. This is x minus 3, or x minus 3 squared, minus 2. And then 144. Write it in standard form. Divide by 144. So x minus 3 squared over 16. Y minus 2 squared over 9 equals 1. So now, we have to do all this work to get the equation which we were given before. Now the center is at 3, 2. The bigger values are the a's, so a squared is 16, a is 4, it's an x value. B squared is 9, so b is 3, it's a y value. So center is at 3, 2. 1, 2, 3, 1, 2. So there's the center. A is 4, it's an x value, so we're going to go sideways. 1, 2, 3, 4. So we're at 3, 4, 5, 6, 7. So we're at 7, that's V1. We're at 7, 2. And then go 4, 1, 2, 3, 4. So we're at -1, 2. And then the b's are 3 and -3, 1, 2, 3. And then 1, 2, 3. So we're at 5, 3. And we get an elliptical shape. And there is the major axis, okay? Which is 8 units. 2a is 8 units. Now to find the focus, a squared is b squared plus c squared. 16 is 9 c squared. C squared is 7. C is root 7. So the focus is root 7 units. Let's see what roughly that is. Root 7, roughly 2.6. So from the center we go 1, 2, so that's right here. This is F1. The y value is just like the y value of the focus. We started at 3 and moved to the right, so we added root 7. Here, let me write it right here. F1, the y value is at 2. The x value, we started at 3, we moved to the right, root 7 units. 1, 2, so the second focus is right here, F2. The y value is 2, the x value, you started at 3 and you minus root 7 because you went to the left. And that's it. And the next section talks about the hyperbola, which we will do